answer at the end.
What we're using is IPv4. I just wonder what... he's going to talk about IPv6 and some of the benefits that will have for us, and how do we actually get to the new wondrous internet from the internet we have now.
Thank you, Tom. I'm the strange guy who wanders up and down the street with a sandwich board saying, your internet protocol matters, and everybody goes, who the hell's that? So it's a weird sort of role, but the Internet Society of Australia has one mission, which is promote development of internet technology in Australia, and that's a very clear mission. And I guess the IPv6 part of the story is that there's some news coming, particularly in relation to the sort of applications that you saw mentioned on the previous presentation. So let's get down into it. I think Tom's already told you most of what I've been doing, but we certainly have been chairing the process for the IPv6 Summit in Australia, which has been running since 2005 and will come up again. And also recently, with some others, I founded a company on this subject as well. I found myself with a weekend to spare in the US, and so I ended up on the very close to the field where Wolverine Wright conducted what turned out to be very extensive experiments with a number of flying machines. And this is by way of kind of giving you a demonstration of the amount of distance you can cover in terms of innovation in what is a relatively short time. But you can see a picture on the slide there of their flying machine, which looks nothing like something like that, the A380. Now a plane that will carry 500 people and do it more fuel efficiently than a lot of other things around the world. That distance, their experiments were conducted in about 1903. By the Second World War, the military was actually using planes as a real device, and 100 years later, the A380 comes on the thing. It's a very short space of time, but I've got a message for you. That's actually a picture of the cockpit of the A380, and I wonder if anybody can tell me what that is. It is a keyboard, not a steering wheel. This is a flying network. That's what it is. Now, I think it's still safe to fly in, but one of the advantages they gained by turning it into a flying network was that they managed to get rid of what's called the wiring loom in the aeroplane. And the wiring loom is a collection of copper cables, all designed to go out to various devices around the entity and turn them on and off and supply them with power and do all that sort of stuff. And instead of that, they replaced it, well, hopefully with not just one network cable, but one or two. So where are we going with all this? Well, the trajectory is, I think, being predicted today, but there's your standard internet fridge, already connected to the internet. That is, by the way, so the kids can do their homework in the kitchen, so you can look over their shoulder and make sure that they're doing their homework and not something else. And here's a driving network. This is a robot car that actually won the latest DARPA competition for robot cars driving around an entity in the US. Again, a driving network. So the theme here, you can see it coming out. All of those wonderful things that we've been talking about are becoming networked. Well, this is IPv4. Can anybody tell me if this protocol is up to the task of networking all these things?
Yes, absolutely.
All right, let's see how we go. By the time you get to the IPv6 addresses, you've got something about that size if the first bundle was your IPv4 addresses. This is enabling a massive, massive internet, potentially. And for those people who want the numbers, V4 addresses, the original number is 4 billion. In the V6 world, for those who can't see it, 3.4 times 10 to the 38. So what is IPv6 about? Well, it's the Internet Protocol version 6. I'll still come to the question of what happened to 5. But we're currently using 4. And I've got to say, I was on this campus to a group of students who weren't in this particular school. But as I talked to them, the first thing I said, I asked them a question: what is the internet? I got 0 answers. They didn't know. They weren't aware. They didn't understand. And so, you know, as I said, I'm the guy who walks up and down the street saying this is the internet protocol and it's important. But I guess what we're finding is that the success of the IPv4 based internet has told everybody this is quite a useful thing to do. And we want to do more of it. We want to have all these things networked. We want to have flying networks, we want to have driving networks, we want to have our fridge on the network, all that sort of stuff. And the point is that the original number of addresses in v4 is a limitation on that. And that piece of information has been known since 1995 at least, perhaps earlier. But the more recent piece of information is that the pool of original addresses that we have for IPv4 at their current rate of usage will exhaust sometime around 2010, 2011. Now, you know, for some of the people in the community, that's not a really surprising thing. They've gone, oh, well, yeah, we knew that all along, and we've been working around it. But for a lot of the policymakers and the governments in the world, this has become a significant piece of information, and it's spawned a rash of resolutions and discussions. Anyway, IPv6 was designed to fix a lot of that problem by increasing the address space, you already saw the numbers, and also allowing auto-configuration. So when you fire up your IPv6 enabled device, it doesn't have to go and consult anything on the internet to begin talking, it just is able to communicate straight away. There's a range of other technical elements attached to that that I won't go into. So in case you didn't understand IPv6 from the past slide, this might make it clear. Well, perhaps. What people are most used to using on the internet is domain names. What we're living with at the moment is the IPv4 based internet, which an address looks like that. And what we're moving to is an address that looks more like this. That is a very short IPv6 address, but it will get you there. Is that right, Kevin? It will. You've tested it, haven't you? The first one doesn't get you there, but the second one does. Or if you didn't understand that, here's a kind of quote from Paul Toomey. The internet is like a 15-storey building, and the domain name system is the columns holding it up. Well, ICANN would say that. I guess I would just add to it that the internet protocol is the foundation on which all of that sits. So unless you've got a globally accessible internet protocol address, you're going to have trouble operating on the internet. So why should Australia be interested in IPv6? The key question, or the key point, is that IPv6 transition is coming because there's a whole lot of people planning that transition as we speak. And I guess the question is whether, on that slide, is it the light at the end of the tunnel or is it something else coming down the tunnel about to rush you? But an early start to transition would give, we argue, Australia advantages in trade, skills development, and also in information. I can rattle through what these countries are doing. Japan's now got millions of paying IPv6 customers. South Korea still has a policy of civilian implementation complete by 2010. China will run the Olympic Games on IPv6 as a demonstration project. India has already, the Indian government has already made decisions about their purchasing policy, but you'd have to say that with the number of people in India and China, that's a prime area for interest. And there is a sort of a north-south dimension to this debate. And if anyone was familiar with the WSIS discussions and the group of 77 countries who were basically complaining that the West was keeping the internet and its benefits all to itself, you will know what that debate is about. In North America, which is probably where we share our perspective of the internet protocol and the internet with mostly, it's been defence there that's led the charge. Ultimately, the US government has issued a mandate that all their backbones will be enabled by the middle of this year. And in Europe, the European Commission has been sending some millions of euros on IPv6 demonstrations. I guess my conclusion out of that is that if those people are going to start talking IPv6 and they're our strategic and trading partners, then probably we should know how to talk it as well. So what have we done in Australia? Beginning of 2005, we set up a special interest group in ISOC.AU. A couple of lead sectors in Australia are the education and training sector, and I think Bob will tell you that already people on this campus are using IPv6 to access their sites in other countries through ARNet, I presume. The National ICT Industry Alliance was mentioned before, and that has resolved that Australia should be discussing IPv6 as of the beginning of 2005, but also it's developed a 10-year strategic vision for the sector, and we're talking about 20 organisations across the sector, and their mention of IPv6 was that Australia should be one of the countries to benefit or maximise its benefit from adoption of IPv6. The Australian government has been there since 2005, sponsoring a range of activities, and I mentioned particularly the IPv6 for e-business project that we put together that spawned a new website. I might just send those on the way around. But a little announced policy change happened at the IPv6 summit last year when the Australian Government Information Management Office announced its transition plan to IPv6, completion due in 2015. I think that date's a little bit late, but they have announced a transition strategy, and as a result of that, they're one of the few governments in the world to have actually carried out the planning for a transition to IPv6. Our government. So, what are our options? We can wait and see. We can wait for our IPv6 exhaustion to set in, and I don't know that that's any particular group of people. Or we can do two things. We can start adopting IPv6 as part of our major infrastructure projects now, and we can also think about IPv6 as a platform for innovation. For me, the second one is really the most interesting one because it provides Australia with the best opportunities, but I'm not sure we're quite up to the task, and I think it's a matter of galvanising this motivation through things such as the 2020 summit to see whether we get there. You've seen all sorts of examples of things we could do already. There's my list of a few early examples of things that we could seriously get into. I think I've mentioned most of this, and you'll get the URL for that website from the pamphlet that I just sent around. But I should say that the IPv6 for e-business website provides a very comprehensive and very carefully assessed set of information about everything you might want to know about IPv6 for Australia, including a downloadable return on investment calculator to say, if I'm this sort of organisation, where is it going to be implemented in my organisation? What are the implications of doing that? And for my boss, here's a nice little report that will spit out an after-tax calculation of return on investment for the money you put into it. And that's where I think the current discussion has been a little bit deficient about IPv6. It's focused very much on the technology. What are the advantages? What are the disadvantages? Community's been working hard on all that stuff, but very few people have sat down with an organisation and done an economic calculation of what this might mean. And if I could just give you an example of that, my understanding is that there are a number of parts of university campuses, at least in Australia, and some of them have made an assessment of whether they should or shouldn't do IPv6. In the end, it was just the cost of the original addresses in IPv4 that said, no, IPv6 would be a cheaper solution. So it can be as simple as that. Okay, so this session is called about open standards, and what I'm arguing is that Australia actually faces a significant opportunity here. And it's very rare that we sit around our rooms going, Australia could do something really meaningful for the rest of the world. Most of the time we spend our time taking opportunities and looking at the other things that other people have done. So why is this an opportunity for Australia? Well, it's because of open standards. The IPv6 standards have been generated off a process that is an open process. You don't have to pay a licence fee. You don't have to pay any access. You just download this information. And to draw the link to the open source community, typically to get a standard up in the IETF process, you have to be able to provide some running examples of this. In fact, 3 of those examples. And usually at least one of those examples is an open source example. so you can see actually what's going on with the code and how it works. That's a very brief summary, but I guess my conclusion out of that is that here is a major opportunity for Australia because it is information-based, and we've already seen the benefits that we can get out of the internet. We start to overcome our major economic problems over the millennia, tyranny of distance and economies of scale. So is this a case of cultural cringe again? I hope not. I think we should stand up there. We already have a position in World 4 on this subject. The Korean IPv6 Summit, the World IPv6 Congress, and we're coming up to OECD ministerial meetings in 2008. Thanks to the national discussion, we will have something to say at those forums. Thanks to the work we've been doing, we already have a transition plan for our national government. These are things that will stand us in good stead in those international discussions. But my question is, are we in a position to take advantage of these opportunities, or are we going to run away? Well, let's go back to the Wright brothers again. The Americans are great on monuments. I don't know if you've been to Washington, but there's really inspiring monuments in Washington, I reckon. Anyway, down on a sandhill, somewhere in North Carolina, is an enormous monument to the Wright brothers. It was put there in the 1930s, and they made sure they got their message across by chiselling it into the stone in the bottom. And they said the Wright brothers got to where they did by dauntless resolution and unconquerable faith. It sounds like a religious movement. Well, I think what they actually did, and if you read a lot of the displays, what you find out is they did very good science. They had a considerable amount of know-how from their bicycle shop, which was applicable to the airline industry in that era. and they also had a lot of commitment. So my question is not really that IPv6 is about innovation. My point is really that IPv6 is ready to use now, and we have plenty of working examples of how it can work. The question is more, can we use this as an opportunity, as the Wright brothers did use their bicycle workshop, to move forward and take up the innovation opportunities that sit on top of IPv6. And Australia is replete with those sort of opportunities. So we need skill, we need competence, we need know-how, strategic approach, and we need a supportive government policy. And so what we need to do is start building those skills, doing transition planning, think about our major infrastructure projects. Certainly the Fibre to the X project is a very prime example of that, but it's not the only one I'm thinking of. And I've written my 500 words, but there's 600 words at the moment. And at the end of that, there's a whole outline of supportive government policies that could be implemented to do this sort of thing. IPv5, we don't go by numbers. It's 4 and then it's 6. There is an IPv5, but it's not in this sequence.
Wasn't it very good?
It was for a different purpose.
Totally relevant to this sort of medium protocol. You never been caught up.
There's also an IPv7, isn't there? Actually, there's up to 10 now. So
Thank you, Tony.
Thank you.
Based on my revised timeframe, we've got time for a couple of questions. So I think we've established there are at least 2 versions of internet protocol.
The IPv6 transition should have been easy. As a software engineer, what went wrong was that the APIs were ill-defined when IPv6 was all the rage a number of years back when it was first being debated. As a software engineer, I tried to convert my code to use IPv6, and I found that making it work on multiple platforms was virtually impossible.
When was that?
Enormous stuff up, making it work on Iris, on
when was that?
Linux, making it all work. It's only now just getting to the stage where the application programmers can actually program to a sane API. And so really, this is getting close to year 0 when it's actually reasonable to program IPv6. That's why it's taking so long.
Fair comment.
The other reason, of course, is that the DNS root servers only got IPv6 a month ago.
Sure, but
12 years after.
Oh, DNS isn't the whole internet.
128 bit addresses all of them.
Yep. Sorry.
So Tony, what are you actually asking the government in Australia? What do you want the 2020 summit to say?
Okay, I want supportive government policies in one line, and I've got a string of about 6 of them that they could support to make this happen. I mean, in the immediate sense, it'd be mad if we started building new networks without having some IPv6 capability in them.
Legislation.
No, that's a specification in a network tender. That's what that is.
It wouldn't require legislation, it would require a decision at essentially a management level within agencies and departments to go down that path. If there was political will at the ministerial level, encouraging and even giving directives in some cases to go there, that would be immensely helpful.
So that's part of the stick part of the equation. That's we're running out of addresses, we should do something about it. On the carrot side of the equation, though, what I'm looking for is a set of supportive policies that will allow entrepreneurs to build on the opportunities around IPv6, and that's the subject matter for the innovation inquiry.